Excellent. Great. I'm Addison Snell with Intersect360 Research. Presentation for today, I was doing slides up until the last minute because I'm trying to do not only a different presentation than I've done at previous HPC advisory councils, but also leverage some brand new research that we haven't even fully delivered to clients yet. We're still tabulating a lot of new things. Some of the recent trends, not only from the most recent supercomputing conference, but really looking forward to what we think are the big deals in 2016, leverage not only what's going on in the microprocessor space right now, which is where there's the biggest amount of change, the most amount of diversity, looking at not only Xeon and Xeon Phi, but what's going on with GPUs and open power, ARMs, FPGAs, the gamut there, but that there's a significant influence in HPC now from the hyperscale segment, and that's something that we've been looking at for a long time. Intersect360 Research is in its 10th year now, doing analysis of the HPC industry, and all along we've tracked what we called ultra-scale internet as an HPC segment because we were aware that companies like Google or Facebook would consume high-performance technologies in order to run their applications at that certain level of scale. But last year it started becoming evident that the hyperscale market had evolved to where it wasn't really a segment of the HPC market. It was really a distinct market in of itself that had some similarities but also some critical differences between it and the HPC market. And we're now examining hyperscale as a distinct proximity market to HPC. And I wanted to talk about some of those trends here because they've been very relevant to the conversations that we've seen in terms of new technologies, new application areas, etc. So starting from HPC, excuse me, as a basis, these are not new numbers. These are in fact getting to be old numbers now because we haven't done 2015 actuals yet because the year is too recently closed. It takes us a few months before companies that are public report their results. There's a few more months of modeling. Then we can create a new 2015 actuals and then build the forecast out another year through 2020 in this case will be the new 5-year forecast. So this is where we've been. I did include it here because it's important to reiterate that at the top we segregate the HPC market into what we call high performance technical computing, which is about 2/3 of the market overall, and high performance business computing, which is the other third. High performance technical, well, I'll get to the distinctions between those on the next slide. It's really been the commercial areas that have driven most of the growth in HPC, although we're starting to see some indicators in our budget map surveys that those budgets could be starting to loosen up a little bit, and we'll start seeing some more growth toward the end of the forecast cycle. One exception there is that I'll tell you now that the energy segment, the oil and gas segment, is going to come in short of where we had forecasted it going back into 2014 when we were looking at 2015 and the out-year forecast there. We just didn't forecast that the price of oil would go this low, and that's beyond our forecast methodology. That's going to cause delays in hardware spending. So although we haven't had yet our full day meeting where all four of us take the gloves off and really fight about the forecast all day long, I will say definitively now that we'll be taking some off of the energy segment. It will probably not be seeing growth there, but rather seeing it shrink from 2014 into 2015, so that'll affect some of these numbers. There have been a lot of other dynamics going on. IBM sold its x86 server business to Lenovo in 2014. That means that Dell became the #1 server vendor for HPC by revenue, barely over HP in 2014. We haven't finished 2015 yet. The early demand side indicators, our survey indicators from end users, would push us to think that HP has had a better year than Dell has had. I would say it's likely at this point that HP will have taken over the #1 spot from Dell for 2015, but I can't commit to that yet, again, until Chris Willard and I have the big fight about it to talk about it. He might come in and tell me the opposite, but I doubt it. What that means, though, is that we're looking at the number one server vendor for HPC by 2014 revenue, which was Dell, is in the process of acquiring the number one storage vendor for in 2014 by revenue, which is EMC. Now, when I say that, a lot of people put their eyebrows up and go, EMC, HPC storage, really? The thing is, without having an intentional HPC strategy, EMC still nevertheless sells an awful lot of storage. And you have to draw the distinction between what's essentially high-performance storage, what you would think of from a DDN or a Seagate or Panasys, and storage that gets used for HPC applications, which is going to get you all of the enterprise storage vendors in there. And by the time you add up not just the enterprise VMAX stuff with or without Scale I/O, but the VNXE line, an awful lot of Extreme I/O that's out there, plus the Isilon business, by the end of the day, EMC really adds up to the number one revenue position. It's unavoidable. The big enterprise guys carry a lot of share before you get down to the companies that are really focused on high performance storage. So that's another critical dynamic that we're going to continue to watch. It's also a huge private take, right? Dell is a private company, and this is the other than Dell taking itself private, this is the largest private take acquisition that we've seen in IT. So it is going to have a considerable effect on the HPC market. Now, when we talk about all these numbers, it's relevant to go over what we count as HPC because it's a little different than what you see from other analysts. When you talk to the average person on the street about HPC and supercomputing, you might use the term supercomputing to make it a little more palatable, avoid the acronym. What people tend to think of first is that green wedge there, which is high performance technical computing, which is to say science or engineering applications, in this case done by public sector research, the government, academia, some defense. That public sector high performance technical computing is 42% of the market worldwide. Beyond that, it's fairly easy to get people to accept the idea of commercial high-performance technical computing because there are for-profit companies that do science and engineering in manufacturing, in pharmaceuticals, in oil and gas, chemical engineering, EDA. There's all kinds of areas where we see the commercial use of HPC in science and engineering. What people tend to forget is the blue area, which is high-performance business computing. That's the use of HPC for non-scientific business applications. Finance is the biggest sector there and is probably the biggest distinction between our methodology and IDC's. We've been counting finance as one of the top or the top commercial sector for HPC for the last 8-9 years. They have not been counting the majority of finance as an HPC market. I can only talk to our methodology, not theirs, but we see a huge presence of HPC for things like risk management, trading, a certain amount in pricing of derivatives, analytics, all deploy HPC. To get a little more detail on the verticals and just the difference in methodology, this is an unofficial chart, but it is just meant to try to line up the verticals between our vertical markets and IDC's publicly stated vertical markets. I don't want to get into presenting their numbers too much, but just to give you an idea, using those same colors from the previous chart, if you look at just the public sector high-performance technical computing, what we would call academia, the national labs, national defense, national agencies, state and local governments. IDC's numbers are about 16% higher than ours are there. They see a higher amount of revenue being spent there than we do. Similarly, commercial high-performance technical computing, the things that we have in manufacturing, biosciences, energy, EDA, areas like that. Again, IDC's numbers have been higher than ours, but overall we have the HPC market bigger because we're counting high-performance business computing markets that they're largely not covering. The funny thing is, if you take just two of those segments that are roughly the same, they're that top one there that says DCC and D, that's digital content creation and distribution, which is an application type that we include under media and entertainment. Their DCC and D number is actually bigger than our media and entertainment number. And the rest of it, they have a very thin line for finance. We have a very large number for finance. We're also counting online games, retail, transportation, a certain amount of public high-performance business computing. If you have like a business school or Fannie Mae, Freddie Mac, those are going to be high-performance business computing applications done by public institutions. Overall, we have a larger view of the market, but they see it concentrated in HPTC, and we see a large HPBC segment. Now, a lot of this is changing. Now, caution about forecasting. This is my favorite quote from my business partner, Chris Willard. When you create a forecast, it has to be bound by what's realistic, whereas reality itself has no such limitations. This is to say that when we do a forecast, we tend to see it. Is this on? I can walk? Great. It'll go up and to the right fairly smoothly according to a growth rate and some market dynamics that you've agreed on. But the reality is that weird stuff will happen beyond the scope of what you actually forecast happening, like the price of oil going to 20 cents a barrel or whatever it is right now. That wasn't part of our forecast. So that'll reduce things going on there, things like wars that we tend not to forecast. Now, if there's anything big going on like geopolitical situations, like the weakness that we've seen in government spending, not just in the US, but worldwide, that does get reflected because it's not only things that we're aware of, but it shows up in our surveys when we ask about budget outlook, and you'll see budgets that are pretty flat, not only in the US government, but the Eurozone has had lots of trouble. The Chinese have had a lot of trouble in government spending recently. There's not really a geography where government spending is good right now. It's kind of flattish everywhere. We do see that starting to release by the end of the forecast period. Servers are the largest segment here and will continue to be, but software and storage are also pretty huge. Software is the funniest one because it's the one that's the most variable by segment. You go into some of the engineering-driven vertical markets, manufacturing, types of areas. Those end users might spend 3 or 4 times more on their Fluent licenses than they do on their hardware. If you go into academia, they spend little or nothing on software. When they do buy software, they buy it heavily discounted. There's a much greater propensity for open source. So that software is it's highly variable, but this is an average across the industry. Another thing to say about software, since I'm on this slide and I don't have a separate chart about it, is that one thing that is affecting this is we do see a transition across the industry away from purchased licensed ISV codes toward more open source on the end user application side. And that's because the increase in multi-core and also heterogeneous computing are stressing the licensing models for the ISVs to where it's more difficult for the ISVs to put together a profitable business model where the end user doesn't feel like they're being gouged on the price of the software. And the fact of the matter is scalability has gotten harder for the software developer, but there's no end users out there who are saying, I really think I ought to be paying more for software. It's really a terrible push-pull. OpenFOAM is the fastest growing application we've been tracking. And that's been happening more on the fluid side. We haven't seen the big structures code emerge yet that'll start challenging some of the dominant structure applications out there like Abacus or CD Adapco, LSTC, Dyna, things like that. But those have been the final strongholds in the ISV space. Server revenue shares, just because I mentioned it. Now, these are already outdated because of what I said before, that we're looking at the 2014 actuals, but it gives you the picture of how close Dell and HP were in 2014, and that IBM still has a sizable share there because in 2014, they still had 3/4 worth of the x86 business that hadn't transitioned over to Lenovo yet. So that's a lot of IBM's revenue that's still up for grabs that'll go to other vendors. Dell, HP, and others will all go up as a result. As I mentioned at the top of the talk, I think the implication is that HP will probably overtake Dell, but we're not prepared to have that on the chart yet. Hyperscale is really my biggest topic I wanted to get to for today. Being an analyst, the unfortunate thing is it puts us in a position where we have to be able to define these things. Normally, you get up and you use a word like cloud or big data or something like that, and everyone will say, yeah, I know what we're talking about. But if you're going to start counting things, you better be prepared to put together an actual definition of what you're counting. This really bothered me in the big data space. Can people hear me when I walk away? Bothered me in the big data space when we started seeing analysts coming out. Big data was really popular. It's going to be a big thing. So I'm an analyst. I want to be really quick to market to say it's an umpty-ump billion-dollar market with an 11% compound annual growth rate. And that sounds really good, except that you haven't told me yet what is one big data and how much does it cost, right? How many big datas are there in your forecast? Like, what specifically are you counting? And in our research, we found that very difficult to do with big data, specifically because in contrast to HPC, where HPC tends to be a separate application infrastructure from your standard enterprise infrastructure. I buy a different cluster to run my quantum chromodynamics than I do for my email server or my payroll database, even if I have both in the same company. That largely was not true for big data. The vast majority of big data was being run on systems I already had, storage I already had, people I already had. So although I might go about saying 10% of my IT budget is now allocated to big data projects, that didn't mean there was 10% more money coming from anywhere. Getting to how much more money there is a much more complicated question. So I don't mean to get off topic on big data. I just mean to say that definitions become important in terms of what you're counting. Now with hyperscale, this is more like HPC in the sense that if you're a hyperscale company, someone like a Google or a Facebook, you tend to have a different application infrastructure for running things like search or the social media application or whatever it is that's your line of business. That's different from your enterprise infrastructure that runs your company internally. Google is not running its corporate payroll database on the same infrastructure it does to serve out people's searches, right? That's a different investment. So really what we're talking about with hyperscale is this notion of companies that have a web scale application infrastructure, which is to say their applications are bound in scalability by how much of the internet their applications touch. And it's easy to give examples of these tier one companies at the top of the market. Your Google, Facebook, Microsoft, Amazon, Baidu, Tencent, Alibaba. You can hit a tier one of 15 companies that spend on average over $1 billion a year in IT for these infrastructures. But then beyond that, there's another tier below that of more companies that have these types of application infrastructures who are influenced by this other top tier. And this is going to be a major focus of our research going forward. We're starting a parallel hyperscale advisory service this year. And because we've been tracking it for this long and have a basis in high performance and scalable technologies, we're really the best analysts positioned to go do that. So when we look at the similarities and differences between HPC and hyperscale, there are critical things that they have in common. Right? You have an application infrastructure that is distinct from your general enterprise infrastructure, which means you can go count it without double counting from other enterprise areas. I'm sure you can find some counterexamples to that, but for the most part this is true, and it makes sense to say out of all of enterprise IT, here's a segment that's HPC, here's a segment that's hyperscale, and here's a segment that's everything else. Another similarity that's important here is that the applications themselves are arbitrarily scalable, which is to say they don't tend to hit a maximum level of scale where you say, if the internet got 10 times bigger, you wouldn't really do search over it. Of course it would. As these things keep getting bigger, you keep adding to the scale of applications, just like in HPC, until someday we wake up and declare that we've gotten to the end of science. There will always be a harder problem to do. You can do these same applications at arbitrary levels of complexity, finer meshes, more degrees of freedom, more realism built into your model. You can make your models bigger. You can make them more complex. So that continued push to greater levels of scalability or performance is something they have in common. And then finally, this is an important one, you have top-tier users who are pushing the boundaries of that scalability and thereby having an influence on technology adoption throughout the industry. In the HPC and supercomputing space, this happens a lot at the national labs, where what the national labs do will push the boundaries of performance and scalability, and the decisions they make eventually percolate through the market. That's true for the Baidus and Googles and Microsofts of the world, where the technology decisions they make in hardware and in software and in standards start influencing the rest of the hyperscale market. Now, that said, it's not sufficient to just say, okay, it's the same thing, we're going to count them as the same. There are important reasons why hyperscale and HPC are different. One that's subtle right on the top is that HPC, your primary focus tends to be on performance, which is to say, at some level, it's a measure of wall clock time, how many jobs I can run an hour, or how long did it take to run this particular job, and can I do it faster? In the hyperscale area, your primary focus tends to be on scalability. Can I do it bigger? Can I scale it out more? Can I touch more end users? Now, there are certainly HPC applications buried within hyperscale, in particular with things like deep learning, machine learning, the deep neural networks that we're talking about. That's a minority of what's going on in the hyperscale space. Really, your hyperscale, for the most part, is driven by the scalability over performance. HPC tends to be driven by performance over scalability, but in neither case is it something like RAS, like it is in traditional enterprise computing, where I don't care that you made my payroll database 10% faster, I just want it to run the same every year, and for God's sakes, don't break it, right? That was always the watchword, that was the distinction between HPC and general enterprise, was in HPC, once you solve a problem, it's no longer interesting. You move on to the next harder problem. You've built that bridge, you build the next harder bridge, right? You find the next chemical. In enterprise computing, once you've solved the problem, for God's sakes, don't touch it ever again, right? Leave it as same as you can year after year after year until you're forced to change. That's where hyperscale comes in, because really they are evolving and changing. This is not a market where Facebook wants Facebook to be the same year after year. They're continuously evolving and trying to build in more types of functionality at that hyperscale level. Because of the nature of the applications, HPC tends to be focused on large jobs, whereas hyperscale is many jobs. The terms large and many are relative terms there. If I have an 8-node cluster and a computational fluid dynamics simulation that's consuming it, that's a large job relative to the cluster, right, as opposed to things like serving out web pages. The notion behind a hyperscale infrastructure is generally to do a lot of a smaller thing. That leads you to another critical difference, is that HPC is still HPC even if you're only doing it on a 4-node cluster. I might be doing an electrodynamic simulation, I'm doing it at that smaller level of scale, whereas hyperscale as a market has a threshold below which doing it is no longer special. I might have in fact I do have a search functionality built into the Intersect360 Research website. It kind of sucks a little bit, it needs to be fixed, I admit that, I have a web project ahead of me, but I in no way consider Intersect360 Research to be a hyperscale kind of company just because we have a search functionality built onto a website. That kind of search functionality is just enterprise computing. It's part of my web server, right? But there comes a level of scale, and your cutoff is somewhere around the LinkedIn Wikipedia level, right? where you say this is now touching more of the internet and becomes a hyperscale application because it's driving a separate web scale application infrastructure that's not part of the standard enterprise computing. Am I making sense here at all? Okay, good. Then there's a difference in the level of scale. The largest supercomputers get up into the hundreds of millions of dollars. Hyperscale tends to run at about 10 times that. The largest hyperscale infrastructures go up over $1 billion. We hear of individual orders that reach the $1 billion or more level from the upper echelon of companies here. None of them will say publicly exactly how much money they spend, but Chris Willard and Mike Feldman have been researching this a lot for the last year, and I think we've got it pretty well triangulated. The largest of them are currently spending about $4 or $5 billion a year on IT annually, and there are several of them that are in that over $1 billion category, and we got a pretty good idea who they are. Now, not a lot of clients are going to pay us to tell them a whole lot about Google and Facebook because they can go talk to Google and Facebook as well as we can. But in that second and third tier below that is where things get interesting, because you do have these other companies in telecommunications, in online retail, in other types of Web 2.0 domains, where there are these application infrastructures that are distinct from normal enterprise computing. That's going to be the thrust of this hyperscale segment. So we've really defined it in 3 tiers. We're going to have a fight about internally whether it should be 4, and we need another split, but under 500 million at around the 100 million or 200 million level. But I don't think the dynamics of that change enough. I'm going to personally argue within my team that we should keep it at 3 tiers, and the third tier is under that $500 million in spending, just because it's not dramatically different there. But within the tiers, you do see a difference in not only the budget size, but the expertise level, the buying models, how much financial leverage they have. One of the hallmarks of the tier 1 companies in this space has been that they've changed a lot of the buying behavior, in that over the last 3 years, really, we saw more of them cut out the traditional server OEM and start going directly to component makers. We had a devil of a time with our 2013 market model when it happened, because the supply side and demand side indicators seemed off, and even within the supply side we were getting confused because Intel was showing a huge gain, huge growth in their high bin processors and citing HPC as a primary reason why, but the primary server vendors who were driving most of the revenue and volume, IBM, HP, Dell, were all off, right? And you go, well, geez, that doesn't make any sense because there's not enough in everybody else to make up the gap, until we reasoned out that one of the biggest contributors to that, although there were a few others, one of the biggest was that some of the top hyperscale end users were bypassing the server vendors and getting components directly from Intel and building their own. So that build versus buy mentality has really driven a lot of the different behavior here. They're also setting the pace in terms of a lot of software. You heard already a talk about OpenStack. They tend to be software innovators at the top end. Again, this is something that they have in common with the national labs, being software innovators. You look at how Lustre is permeating the HPC market. That's driven a lot by the national labs at the top end. You have these influencers in the top tier. Now, that's not going to drive everything. Some of this goes into standards. So I was already talking about OpenStack. There are also new languages, new algorithms, new standards. I was just talking with my team. We're going to have to get an eyeball on the Go language that's coming out of Google. HPC has always, in the amount of time we've been tracking it, HPC has been pretty much 25% C, 25% C++, 25% Fortran, and 25% everything else. And whatever the languages du jour are that everybody keeps talking about, just change what's in the everything else. And the other things have all stayed the same. I think, although it's barely a blip anywhere right now, Go is one that we're going to have to look at because it's a language that's being specifically designed for parallelism, and it's got Google behind it. This could become, in the long term, another area where hyperscale has an influence back into HPC. You see things like the square kilometer array is running on OpenStack, right? This is technology coming from hyperscale back into HPC. New application areas, particularly in cognitive computing, machine learning, artificial intelligence, deep learning, whatever you want to call it. It's got a lot of different faces here that are related to the same thing. But these types of deep neural network kinds of architectures where the technology is being deployed do have a significant chance to have a significant long-term effect on HPC. Right now, the amount of revenue that you could tag on those is relatively small. It's kind of in the other area. It's most significant if you're someone on the processor side, like, for example, NVIDIA. It makes total sense for them to get up and give a presentation on this because it's a huge potential growth area as a hyperscale company like a Baidu or a Google starts integrating GPUs to do those kinds of applications. But overall, server revenue, software revenue, there's not a lot getting driven yet by those kinds of applications, but it is a potential high growth area. The so-called competing standards, which is an oxymoronic term I've always liked, right? Well, which is it? Are they competing or are they standard? But that's exactly what you have on the hardware side in hyperscale right now, between things like Open Compute Project, which is driven mostly by Facebook, but a consortium of other American companies. I only became aware relatively recently that there's a completely parallel development called Beiji or Scorpio among the Chinese companies that Baidu is predominantly behind. These standards are interesting in ways that blew me away if you're going to go serve this market, down to the point where they were saying, well, here's our 48U rack. And I'm going, well, 48U rack doesn't really make a lot of sense to me, right? It's too big. You can't ship it. How would you have a 48U rack, right? I'm used to thinking 40, 42U racks. Oh, no, we changed how much a U is, right? You know, and I'm thinking, no, a U is, I mean, the whole time I've been in the industry, a U is 1 3/4 inches. I know how much it is. You can't change what a U is. No, they've done it, right? You go into Open Compute and Scorpio, and they have, even between them, different a U in each of those is different from what it is. They're smaller, right? And Scorpio has been through 2 different definitions of what a U is. They've even changed it between V2 and V3. So think about what that means if you're going to be an ODM or an OEM who wants to serve this space. You talk about having different SKUs for a certain set of customers. This is an entire different form factor, right, that you're setting up. But the big companies here drive enough volume that they can set the market and say, I don't want it to be 1 3/4 inches. I want it to be, 1.582 inches, however big they want it to be. That's how they want it to be. Then that winds up influencing the rest of the hyperscale market because that winds up being a SKU that's available to sell through the tier 2s and tier 3s. The ODM market has a big role here, right? It's certainly there are OEMs that are serving this, right? You go to Lenovo or IBM or Penguin, and they've got big strategies about how to sell to this market. But they're not only competing with each other, they've got to compete against, and then you think of Supermicro. Okay, sure, Supermicro can put together stuff from this. But then it's not even traditional server players that you think of. You can go to any intelligent manufacturer like Flextronics or what's the one in San Jose? I'm just blanking on it now. Jabil, right? They just opened their whole Blue Sky facility. Then they show off their intelligent vending machines and robotics and things like that. And then you go past this room that nobody cares about. They go, oh, yeah, that's our cloud room. I'm the only dork on the tour who's interested in it because I look on the wall, and on the wall it says Open Compute Project, Open Power, OpenStack. And I'm thinking, these are all open standards, and if I can just go to an intelligent manufacturer and say, build me 500 racks of this, they'll just build it, right? And that becomes a big competitive dynamic in the hyperscale market going forward. Okay, sorry, I left one off of this. Deployment of high-performance technologies. It's not just the scale-out technologies like low-bin processors and ARM and Ethernet that are part of hyperscale. As you get into the areas like the deep learning or the artificial intelligence, you do get the deployment of GPUs, InfiniBand, other types of high-end parts here. Again, these tend to be from a percentage of the overall infrastructure. I don't think Tencent is out there enabling their entire web scale infrastructure with GPUs and InfiniBand. But there's a segment of it that they are. And that's going to drive, again, more of these configurations in more places. One of the big competitive dynamics we're looking at is the Intel and Open HPC and Friends versus IBM and NVIDIA and Mellanox and OpenPower and Friends, and how that'll continue to evolve over the next couple of years. What do you do if you're, say, Dell? Right? Dell has a huge position in HPC right now, but their primary node that they sell is an Intel microprocessor server with a Mellanox InfiniBand and 4 NVIDIA GPUs, which they can sell today. I'm just not sure what that SKU looks like in 3 years. Right? Because Intel is going to be on the Xeon Phi and Omni path and scalable system framework path, and I don't know how that evolves to where it includes InfiniBand and GPUs. It could. And the biggest wild card in how that evolves is actually this market. Because if there are individual buyers who are so big that they can say, I want you to make us this, and then it exists, right? That's actually more buying power than you'd find at a national lab, which is pretty impressive when you think about it. So that's another reason that dynamic is out there, and we have to continue to track it. Now, that said, as I close in on the end of my talk, one of the biggest trends we were talking about at SC15 is accelerated computing, which has clearly hit a tipping point. And in fact, we did a bit of additional custom research on top of the application information we already had, and found that of the top 50 most commonly used HPC applications, 2/3 of them now offer at least some form of GPU support or optimization. That is a significant tipping point. The ones that don't are clustered more in the manufacturing space, particularly in structures, but 2/3 of the top ones do. 9 out of the top 10, if you include Gaussian being under development. And this has really been a big trend forward, and it shows a big lead that what's the best noun? Ecosystem. That ecosystem has over the Intel ecosystem around Xeon Phi. Intel has a considerable advantage in being a huge market share leader on the microprocessor side and being able to integrate a lot of that stuff directly onto the motherboard. It's essentially a server on a chip strategy. But they're behind on the application infrastructure as of today. Intel's ability to close that gap or not is the biggest interesting area of research, and we've done a multi-client study on it that's just finished that had 269 respondents specifically on the processor outlooks for HPC. I have thumbed through the results, and let me tell you, there's fascinating stuff in there that I'm not going to present all of now because A, I'm running out of time, and B, I did that on purpose because you haven't paid for it anyway, and I'd like to sell this. But suffice it to say that we're looking at the current usage, planned future usage, evaluation of all the different processor technologies that are out there. I've listed 6 major ones. Believe me, we found others. We're asking about things like DSPs and quantum processors. It's all in the study. Not only what are you using it now, are you planning to use it, how are you going to do that evaluation, what's the influence of hardware features, software features, programming languages, programming models, what's your future perception of these things over the next couple of years. There's enough data there that we will put together our forecast of adoption of Xeon Phi versus OpenPower. Open power, I will tell you now, is going to put up a score that's high enough to be interesting. That was going to be the biggest question going on here is, can open power achieve enough share in the next couple of years to be interesting relative to Intel? Without giving the exact numbers behind it, I'll tell you that's yes. It'll be enough share on open power that it's an interesting part of the conversation. Also, we squeezed in, because it was similar, a small, just one or two questions on some of the architectural and interconnect elements around that, because we had to get a quick look at InfiniBand versus OmniPath. We didn't do a whole lot on it because the primary focus had to be on the processor side. But InfiniBand versus OmniPath and other things like CAPI and NVLink and GPU Direct that are in there also becomes interesting. I will tell you, without putting up all of the numbers, and because I don't want it to show up on the slide when people download it, but you came to the conference, so you get this right while you're here. InfiniBand had the highest scores out of everything on future outlook, right? How do you feel about this interconnect going forward? InfiniBand was way ahead of everything else, like measurably ahead of everything else that was on there. But did OmniPath put up a high enough score to be interesting? Yeah. You bet it did, right? There's going to be enough evaluation of, especially considering how new it was for this survey, what are your views on OmniPath? We get enough people with awareness and a favorable disposition toward evaluation of OmniPath that it becomes interesting. It's not as high as InfiniBand is, but it's interesting. What this means in the future outlook for open power, which goes well beyond what I can possibly put on a slide right now, but open power is interesting enough, or power, I should say, is interesting enough in how much can it be adopted just on its own. But the real strength of open power right now is the ties power has to GPUs and to InfiniBand, because the end user perception of GPUs in InfiniBand is actually higher than it is of power in of itself. So it gets into this funny position where IBM needs its partners in this as much as its partners need IBM. It's really a fascinating dynamic going on in the market, and one that we're going to be thrilled to continue to watch evolve over the course of not just this year, the next couple of years. And it's one that I'm glad we have a lot of good data on. So that's going to be fun.